You know, when we look into the deep ocean, we find creatures that are so bizarre, they honestly feel like they could be from another planet. And out of all of them, the octopus might just be the most alien, the most wonderfully strange of them all. Today, we're going to break down the absolutely incredible biology that makes this animal a true marvel of evolution.
Okay, so let's just dive right in. It's a fantastic question, and it gets to the very heart, or, hearts, of what makes an octopus tick. These aren't just random, weird quirks. They are the absolute key to its survival.
To really get a handle on these features, we have to stop thinking of them as weird. We need to start seeing them for what they really are. These brilliant, highly specialized solutions to a very, very difficult problem. And that problem? It's the ocean itself. I mean, think about it. For an active, intelligent predator, the cold, oxygen-poor water of the deep sea is an incredibly tough place to make a living. Our own physiology, our iron-based blood system, it would just fail down there. So evolution had to come up with a totally different game plan.
So, what was evolution's first move? Well, it was to completely re-engineer the blood itself.
Right, so instead of hemoglobin, the stuff that uses iron and makes our blood red, octopuses use something called hemocyanin. It's a protein that's built around copper to grab and transport oxygen. And yeah, that copper is exactly what gives their blood that distinct blue color when it's all gassed up with oxygen. Now, this slide really lays it all out. On the left, you've got our blood. It's great for us, warm-blooded creatures on land. But look at the right. That's the octopus's blood, a true specialist. It is way, way better at grabbing onto oxygen in the exact cold, low-oxygen water where an octopus calls home. And this table just drills down on that trade-off. You can see right there, hemocyanin gets a high for efficiency in the cold. That's a massive survival advantage. But, and this is a huge but, there's a catch. Overall, it's just not as good at carrying oxygen as our hemoglobin is. And that creates a whole new problem. So this leads to a really fascinating puzzle, right? How in the world do you power a creature that's super active, has a giant brain, 8 complex arms, all with a fuel delivery system that's frankly less efficient?
The answer is just so elegant. You don't change the fuel, you upgrade the engine. You build a more powerful, more specialized circulatory system to pump that fuel around.
And the core of that upgraded engine it's just an incredible number. It's not 1, not 2, but a total of 3 hearts, all working together in perfect sync.
So here's how it works. It's like a little factory line. 2 of the hearts, they call them the branchial hearts, they have one job and one job only: to shove blood through the gills at super high pressure to soak up as much oxygen as possible. Then the third, much bigger heart, the systemic heart, takes that freshly oxygenated blue blood and blasts it out to the rest of the body.
And that body has some serious demands, mostly because of its truly alien nervous system. People often say an octopus has 9 brains. You've got the central one in its head, and then a complex bundle of neurons, basically a mini-brain in each of its 8 arms. Powering that whole distributed network takes a massive, constant flow of oxygen, which is exactly what that 3-heart system is designed to deliver.
But, and here's the twist, this powerful, custom-built engine has one of the strangest trade-offs in the entire animal kingdom. It's a weakness that basically defines the octopus's entire way of life. So let's take a look at the price the octopus pays for having this incredible high-performance system. Okay, get this, because this is wild. When an octopus swims by jetting water out of its siphon, its main systemic heart, the big one sending blood to the body, it completely stops beating. Just stops. Imagine trying to run a sprint while holding your breath. That's why they get tired so incredibly fast.
And this one biological fact, it explains so much about how they behave. It's why they almost always prefer to crawl along the seafloor with those super smart arms. It's why swimming is always done in these short, powerful bursts, perfect for escaping a predator or ambushing prey, but never for a long commute. Their entire life is a masterclass in managing their energy budget.
So when you put all these pieces together, the blue blood, the 3 hearts, the way they act, you start to realize this isn't a weird system at all. No, it's a perfectly tuned engine for a very, very specific lifestyle. And we can see just how specialized it is when we compare them to their relatives. That 3-heart system, it's also there in other active predators like squid. But if you look at their more ancient, slow-moving cousin, the nautilus, it just drifts along with a much simpler heart because, it just doesn't need that kind of high-octane performance.
And make no mistake, this system is ancient. We're not talking about a new invention here. The basic protein for their blue blood is over 700 million years old, and the three-heart setup probably evolved over 400 million years ago when these animals started becoming more active hunters. It has been fine-tuned by natural selection for eons. But being so hyper-specialized, so perfectly tuned for one kind of world, that actually creates a modern vulnerability. The efficiency of their blood is extremely sensitive to the pH of the water. So as our oceans absorb more carbon dioxide and become more acidic, it actually makes it harder for the octopus's blood to do its job. It's a direct threat to the very system that made them so successful for millions of years.
So let's just recap the big points. The blue, copper-based blood is a specialist tool, perfect for the cold deep. The three hearts are a supercharged engine that makes up for that blood's lower efficiency. And all of this unique biology directly shapes their signature behavior, especially their love of crawling. It really is a stunning masterpiece of evolutionary problem solving.
Which kind of leaves us with one last thought. The octopus seems so alien to us because it's perfectly built for an environment that we find completely hostile. And it just makes you wonder, what other incredible, seemingly impossible biological solutions are out there right now, thriving in places we haven't even discovered yet?